Thank you.
Thank you. RD equal 1 over.
1 over lambda OS.
Yeah.
One more. There you go.
And let's see. Oh, add what they given you.
40.
Here. Right here. YOS.
40 micro.
40. So what you get? I think I get
25.
25 watt kilo ohm. Okay. Then they want AV. Minus GM R big D. And if you want, you can calculate the AV minus GM times R big D parallel with R small d. So what the gain equal without RD?
Without the little r,
0.5 N.
it would be equal to R, big RD times,
Yeah, GM minus GM times R big D. That's without R small d. What you get again? They will be equal to V out.
I got 0.94.
3.75.
Okay, I get this one. You verify for me. Minus 3.76.
Where you got 3.76 from?
what is big RD? How much is big RD?
Look over that right. 2K.
2K.
You say big RD right here. 2K.
Right.
Where did you get 3.76 from?
And my calculation, I can give it to you. Minus.
I agree. It is 3.76. Okay, here's the deal. GM is equal to 1.88 millis. And then if you multiply that times 2K, you get 3.76. And then there's a minus sign in front of it.
Oh, okay. I thought that was minus GM he was putting down. Okay, sorry.
3.76 is right, Mr. Pham.
Mr. Pham, what does it mean, the lambda OS?
That is admittance.
Admittance? Admittance?
Yeah, admittance.
Oh, admittance.
Yeah,
admittance.
Let's see where they say. Okay, let's see. Right here.
Thank you.
You're welcome.
You got a lot of new good stuff here, Mr. Pham.
Yeah, I want you guys to be very good on this part. The thing is, this they're using a lot. And the people like myself at working, they don't know much about this thing. The thing is, at the time I graduated university, they're not teaching JFET. They're not yet, you know, completely development later on.
Mm-hmm.
So I started teaching 1985, but around 5 years, stuck at the 5 year when we started, we're not teaching anything about the JFET. G0 means output impedance. Try to get along with that.
Mr. Pham, can you do the last AV? How much did you get RD per or?
You mean
The last one? The last
one?
Yeah.
Okay, last one, the same thing. First thing you calculate the RD parallel R small d.
Oh, yes.
Okay?
Yeah.
So this will be due a 2K times 2.5K, right? We just calculate.
Oh, okay. Yeah.
Okay?
2K in parallel with
25K.
2K in parallel with 25K comes
Right.
out to 1.85K. That comes out to 1.85.
Okay.
Okay?
Okay, I got it.
Yeah, good. What I like you guys to do a, you can
348 negative.
doing
Yeah.
a calculation
Like
quickly. If you can memorize the formula, that's good. But normally, they give to you the formula. And also when you get a quiz or a test, I given you the formula. You don't have to memorize. If you can memorize, that is the best. Even myself, teaching year to year, I still cannot memorize on that formula. Okay, now next, common sort. We already done, right? Okay, so this is really, you can see on this circuitry here, I like that kind of the display. They just very good for the technician. When you're looking at the circuitry, you know there's a common source. And also, you can see this is the input here, this is the output. They will be our phase, opposite. Okay, so now, common source again, okay? They just given you general formula. Input equal R here. Input impedance, okay? Output impedance, you can see they say R big D parallel R small d. However, R small d much bigger than R big D, then they want this formula, okay? They don't want this one. Take more work, okay? And the voltage gain, that's just summarize, okay? Voltage gain, you want V out over V in minus GM times RD. The thing is, they suppose ignore the R small d. If you want R small d in your calculation, then you're using this formula, okay? I given both formula. That means for the technician or for the people who go up to the university, then when they're talking about that, you know what they're talking about. And the phase relation, common source amplifier configuration at 180 degree phase shift between input and the output. Okay, and now we try one more example to complete this common source here. Okay, so they given you the circuitry common source bias. However, on this circuitry, what the DC bias they're using?
Self-bias.
Cell bias, that's very good. Cell bias. You must be memorize those kind of circuitry. Okay? The thing is normally they're asking you, they're just asking you general. What the DC bias? But you don't have to do any calculation. So cell bias, and normally you understand the cell bias, you need the graphic in order to solving the problem. Without the graphic, then they must be given to you. For example, they given to you 1 volt, Vs equal 1 volt. And they want to calculate the VGSQ, IDQ, and so on. Okay, now, let's see, you can do that better for me, quickly. I need to add in the pay, okay? So I can draw it for you. Add the pay. Okay, see what they want. They want VGSQ. Okay, VGSQ ID. Okay, we want to calculate the ID first. Equal IS equal VS. Okay.
Next question.
I'm looking for the circuit. RS equal 200 ohm. 1 volt. See what you get. Okay, 1 divided by 0.2. You get 5 milliamp. And the next they want IDQ here, okay? And now I want VGSQ. Okay, VG.
Minus 1 volt.
VS. Okay. That equal minus
1 volt.
1 volt. V0, 0, okay?
VG equals 0.
Yeah, VG equals 0. Okay. Then next one, they want VD, GM0, GM. Okay, they want VD. And you understand VDD minus ID time RD. Okay, VDD 15 volt minus ID, we already calculated 5 milliamp time 1.5K. Okay, 5 times, let's see, 15,
7.5.
7.5. 7.5, right?
Yeah.
Okay, good.
It's 15 minus 7.5, which is 7.5.
Okay, then they want GM0. Okay, a 2 times IDSS divide VGS of IDSS, they given to you a 10 milliamp. VGS of minus 4. Divide 4, you get 5, right?
$5 million, yeah.
Okay, then now you want GM. Then you get GM0. 1 minus VGS. Okay, GM0, 5 times minus VGS minus 1 divide VGS 4, S of 4.
So that's 0.75 times 5 million. Did you get 3.75? Did anybody get 3.75?
2.81 should be 1 minus 1/4 square.
I think I get 3.75.
That's what I get.
Okay. And now they want the gain.
Mr. Pham, isn't the equation got a square in it?
No, that's under current.
No, GM is equal to GM0 times 1 minus VGS over VGS of square.
That's for the current. The square is for the current. For the GM, they don't have the square no more. Hey, Mr. Pham, can you look up that formula so you can see it? Because I don't believe you have the square on there. I know what he's talking about.
That's
but
what
I don't
think. That's
I don't think.
Oh, stop.
That's what I think so. Yeah.
There's no square, right?
Right.
Okay, I'm wrong.
AV will be using the load only, not R small d. We don't want to play with that. Just quit the term. So they will be equal minus GM time R big D parallel and just telling me what you get. Try, make sure you can do it. The next quiz, next week, you can have a no problem. Minus GM means minus 3.75. Time R big D 1.5. 1.5 time R load 10K divide 1.5 load 10K.
Do you get an AV of 5?
Minus what?
I mean minus 5.
Anyone else get the answer?
Minus 4.89.
Aha, how come you guys get a different?
Okay, wait a minute, hold on.
I already put everything. 3.75 time with combination in parallel.
So 15 divided by 11.5. 0.75. 4.89.
4.75.
Minus 4.75.
I get 4.89.
4.75.
4.89.
Oh man.
Yeah, 4.89.
4.89.
Come on.
Anything else is wrong.
So
It's 4.89 negative. Yeah.
I follow a majority.
Way to go, Mr. Pham.
Okay, I'm not doing on this example. save for the quiz next week. I try to explain for you guys how they're working. So this circuitry, they're using the same cell bias. And we already said cell bias, they need a graphic, but we don't want graphic. So that's why we given to you the current ID, 1.95 milliamp. And that ID here means IDQ. Okay, so you already get the current ID. Then you can calculate the VS right here. Okay, VS will be equal ID times RS. Okay, I just make a note here for you guys. Okay, you can calculate the VS equal ID. That will be 1.95 times 0.910. Then whatever you get, okay? And now they want VGSQ. VGSQ equal VG minus VS. And that will be 0 minus VS.
Hey, Mr. Pham.
Yeah.
So this is, you said this is self-biased, this circuitry.
Right.
Okay. I thought that it was self-bias only had a single voltage source, but this...
No, single
Okay.
fixed bias.
Say that again?
Fixed bias, then you get the voltage here.
Okay.
That's a fixed bias.
But this is self-biased, this circuitry.
Exactly. The thing is
Okay.
connect to the route through the
Oh, okay. Okay, I got, oh yeah, I see. Okay. Thank you.
Mm-hmm. Then if you want to calculate GM0, you know how to do it. We already do it. Just calculate the GM, and you can do GM. Input impedance, you know, that will be RG 10 mega ohm. And the output impedance, okay, I gave it to you on this circuitry here. Output impedance, G out. RD. Okay, we not do calculation for R small d. No load for this circuitry. And if they want the gain, I given you the formula for the gain. AV minus GM
RD.
time G out. That means time R big D. And if they want to calculate the V out, then you know V out equal V, now V out equal AV.
V out equal AV times VA.
Exactly. That means I've given you all of the things you need to complete all those calculations for this circuitry. If you're done, then let me know. We can go to the next one.
Go with throttle up, Mr. Pham. Go.
Go. Now go to another one. Common source, common follower, common drain. Okay? Common drain, they get another name, short follower. Even they say short follower amplifier or common drain will be the same thing. Okay? And now, in general, I can tell you how do we recognize common drain. The input applied to the gate. However, output will be from the source. So that's why they say short follower. The thing is, when capacitor shorted for AC, V out or Vs will be the same. Okay? And input impedance from the input look into the amplifier. You can see easy recognize G or whatever. Or G out. That means you're looking from the output into the amplifier. Okay, they said in a common drain amplifier configuration, input is on the gate, but output from the source. Okay, now this is the AC module. Okay, AC module here, I gave it to you. Okay, this is inside. Okay, JFET. And this is, you see, on that one, they get a small d. So basically, this coming again, come on the document from one of the university. Okay, so we don't care on small d. So in here, they're telling you input resistance RG. However, output resistance will be equal RF parallel 1 over GM. And the gain, they give it to you GM times RF divide 1 plus RF. We'll see, do we do a calculation here? Right here, okay? Right here, we will show you how to calculate the output impedance. Okay, so when you're looking in here, you can see this will be RF here, and this is the current source. Okay, going from the drain to the gate, GM VGS. And now in here they explain to you how do we determine G out. First thing they say, I out equal IRS, okay, minus GM VGS. You understand here. This is the output here, okay? Then for the resist current, IRS, so the current will be go this way. That IRS. So basically, the current IL will be equal this current and this current IRS. Okay? Current GM VGS opposite to the IL. So that's why they get minus GMVGS. However, this current I here going the same way as the current I out. So that's why they say IRS minus GMVGS. Okay, then you can follow in here. Finally, they can get to you to the formula right here. GL will be equal RS in parallel with 1 over GF. Okay? And if you want to do a calculation, also include RD, that formula here for include RD. Okay? And then you can calculate the gain AV. What we're using will be this gain. We don't want to using another one. They including small d. That only thing what I want. When I given you the test or the quiz, I given you the formula. Okay? No way we can memorize on those kind of formula. And even we don't need to.
Mr. Pham. Mr. Pham.
Yeah.
Can you explain the part about the current? I don't quite understand why is it IRS minus GMVMS. They look like they're in the same direction, aren't they?
You see it right here. Data point here.
That's positive.
Data current here. GMVS, right?
Yeah.
And this is the current IRS.
That's
Okay?
going down, right? Yeah.
So at this point here, coming out here, that's what they call IR.
Oh, okay.
Okay? So basically IR opposite GMVGS. So that's why you get a minus here.
Okay. All right.
Okay? Yeah.
Thank you.
Anything, just bring it up. If I can answer, I do. If I cannot, maybe I need a Richard help me. But that's for engineering, okay? We don't want to waste the time on that. Even only thing when you go to university, then you have to be consider everything here. Okay, now what we want, try to get this done for today.
Mr. Pham, short question.
Yeah.
Are you continuing teaching this kind of topic the next coming quarters this year?
No, not summer.
Not summer. Okay, summer we're going to see again a parallel and series circuit, I guess.
Oh, that will be on the, you mean for the JFET or you mean for the DC?
JFET, I'm talking about what you had been teaching this last week. It's very interesting, but to me, it has been a little bit tough to understand, learn everything. So just wondering if you are going to continue teaching this topic in the future, in the near future.
Yeah, for sure. That will be happen on the fall.
Okay. Thank you, Mr. Pham.
On the fall, then you can see it will be more things.
Okay.
I'm not using the one I already given teaching to you. I have to go over. I say, what do we need to add in more? Okay?
Okay. Thank you. Thank you.
On the summer, only one course that will be AC only. That only two
Got
months.
it.
So only AC will be teaching on the summer.
Okay, got it. Thank you.
Yeah, you are welcome. I try, keep go over and over until you're doing a good job for me. Let's see, that one we want to do on that part right here. Okay, let's see. Okay, I want to do that problem. Yeah, that problem here. Okay, so let's see. This will be slide 21. 21, 20. Okay, 21. Okay, on 21 here, they already given to you everything you need. They want to know GM0. Okay, GM0, we already know they will be equal to time ID. Okay, and ID at 16 milliamp. Divide VG at -4. Okay, for my, I get
8 milli.
Okay, good. Then the 1 GM0 1 minus
VGS.
GS over.
VGS off.
Okay, for my 2.28.
How much is VGS?
Okay, so GM, I get 2.28. See, anyone agree with that? Or you get different?
What was VGS and VGS off?
-2.
I guess 6 actually.
How come we get different?
If VGF off is 2, then
VGF off is -4.
minus VGF off is -8, isn't it?
-4.
I think it's -8, isn't it?
Oh, this circuitry here, right?
Oh, okay. I'm doing a different one. Okay, I got the wrong one.
Okay, that's good.
So VGS off was 4 then.
Yeah, -4.
How come you have pinch off was -4? Hey, go back to the circuit, Mr. Pham. It says VP equal -4.
Yeah.
So once again, you can't have VP -4 and VGS -4. They both can't be -4.
Right. On this one. But the thing is they get it wrong. They're supposed to give an VP equal +4.
Okay. So you need to cross that out.
Right.
Make it +4.
Right. The thing is we still can get a MOSFET for the amplifier. I will be going back to the guy on the bipolar. Those things will be very important for the technician. Then I think after that you can get much better. Okay, GAM already done. Then they want input impedance. One mega ohm.
Yeah.
And they want output impedance. Okay.
2.2.
Output impedance. The formula will be RS parallel 1/GM. So you need to know what the 1/GM.
.44.
Okay, so you get 0.44. 44K. KO. So if you get out what I get, 316.5. .69. Oh. Is it ohm or KO?
Hey, Mr. Pham.
Yes, sir.
1/GM, which is 1/2.28, that is equal to, because that's the same as taking a reciprocal of 2.28 milli, and that's actually equal to 4.438 0.59.
Now that you will go to the kilo, right? The thing is the other one is milli. So basically, if the people want to make sure you can get 1.2.28 milli, you need to convert it to diamond.
I know, but what I did is
Put it through.
Then you need to time 10 minus 3. So
yeah, if you take the reciprocal, because basically that's taking a reciprocal. So if you take the reciprocal of 2.28 milli, it should come out to 438.596.
you know what I'm saying? When you try to take a reciprocal 2.28 m diamond, you need to convert into a diamond. That means you have to multiply by 10 minus 3.
Yeah, I know. I changed it to I changed the 2.28 to 0.00228.
Okay, you
And
take
then
a
take the reciprocal.
you take a 1 divide to 28. What you get? 1 divide 2.28. I get 0.438.
Yes, 4.
Oh well, 4. Okay, I see what you're doing, because you putting it in K, but we're basically we got the same answer.
Okay, is it you get a GL equal 365? Who got up to that point?
And that is equal to, so. I'm sorry, what was RS again?
2.2 kilo ohm.
Yes, it's correct. I got 367.
Yeah, I got the exact same answer Mr. Pham got. 365.69.
Ohm or kilo ohm?
It's ohms.
Okay.
Oh.
So good.
Yeah, that's the right answer. 365.69. Oh,
okay.
That's right.
AV. Formula for the AV. Okay. Let's see. AV GM times RS. I try to see I can do this thing. No. Okay, GM times RS. Divide 1 plus GM RS. On my, I get 0.83. Okay, then I will be stopped now to let you guys take a quiz. Make sure you download the quiz number 17 report. You understand it the first time you run for the JFET amplifier, you not really understand much. However, next time you get better, and next time you get much better. That's why I told you for like, software C++, you want to know how understand, keep reading over and over, 100 times. Okay, so I stop share on my iPad to get the quiz going. Okay, let's see where the quiz.
Thank you.
Oh man, how come? Just a minute. Okay, let's see. 17 key. Nine, 14, 17. Okay, here. Normally, when you see the display for the green in the back, that means it's coming out from the left phone setup. When you do your left phone, then you can see again. That will be helping you to get through easier.
Okay, we cannot see the page. It's very small.
How come? You cannot see A?
Looks fine to me.
It looks fine to me here.
It looked good.
Okay.
So that may be not my problem. So basically depend on the computer.
I can see it pretty good, Mr. Pham.
Okay. Okay. You see, I can the way trending a lot. That take me too much time.
Okay, I got it.
Okay. Good. Anyone they not done it today, they want to done it, they have to go into the video. Normally, after tonight, I upload it in the morning, you can see it.
Sorry.
Number 10 is safety. Number 10 is safety.
What do you mean safety?
The proper way to lift a heavy object. It's not electricity.
Basically, that coming from the lab form.
Oh, okay.
And I think that will be really help for everyone. Not related into the electronic.
Mr. Pham, can you show number 4 once more at the end? Number 4.
Okay, I have to finish that. Then we will tell you number 4, right?
Yes, please.
Okay. Number 4.
Okay, thank you.
You are welcome. So, Mr. Sam.
Number
Yes,
2.
Mr. Pham.
Okay, you prepare for the correct answer and show them on next Wednesday.
Yes, sir.
Hey, Mr. Pham, let me see number 2. Number 2.
Oh, man.
Hold on just a second.
Yeah.
All right, thank you.
No problem. We'll see you guys next week.
Okay, bye-bye.
Bye-bye.
Bye.
Thank you. Goodbye.
Goodbye.
Hey, Mr. Sam.
Yes, sir.
Fine, fine.
Hey, could I ask a question on my on that C++?
Sure.
21. Okay, so let me get this up real quick.
Okay.
Okay, I'm going to share with you.
All right.
So, okay, so a couple things. Do you see it yet?
It's coming. It's still
Okay.
black screen.
Okay.
Okay. So we're doing a common collector. Okay.
Yeah, common collector, but you see over here on the right on this section here,
Mm-hmm.
I'm not sure why I'm having the common emitter app on there. I think I might. I don't know if I used part of the template for that and pulled it over and then, or what happened, but.
Yeah, it looked like, yeah, you probably named the same.
Okay.
Yeah, your source code, you name it the same thing as the CE amplifier.
So I'll start another project and then just pull this stuff over and put it on the new project.
Yes. Okay.
Okay. So I guess I need to do that first because everything here I seem to get a pass on, but I was able to check it the other night. I can't remember, but except for let's see, except for 10.
Okay.
I don't know. I tried to analyze it. I don't know.
Okay,
exactly.
so so this is the 3 resistor. So this is 3 resistor in parallel. So that means it's going to be so the Zn is equal to 1 divided by the quantity 1 over R1 plus 1 over R2 plus 1 over Zn base.
Okay, wait, say that again now.
Okay, it's going to be Zn equal. No, you want to write on a sheet of paper first, and yeah, okay. So it's going to be Zn equal.
Hold on one second, Mr.
Okay.
Let me just grab a piece of paper. Okay, go ahead.
So Zn equal 1 divided by, and then you want to open up the parenthesis, 1 over R1 plus 1 over R2 plus
Hold on a second.
1.
Hold on a second. So
Okay.
Zn equals 1 divided, then parenthesis.
Open parenthesis, 1 over R1.
1 over R1. Okay.
Plus 1 over R2.
Plus 1 over R2.
Plus 1 over Zn base.
Plus 1 over Zn base. Okay.
And close parenthesis.
Okay. And then close parenthesis. Okay. All right. That sounds good. And then I I was getting frustrated with it, so I just kind of stopped on that one.
Yeah,
but the rest
that's
of them passed.
Yeah, that's to represent that there's three resistors in parallel. So if you could go back into the first handout, teach you how to do the calculating the.
Which handout?
It's the first handout from the website. When that was the first thing that we're talking about, series circuit, parallel circuit. Remember that?
Yeah.
Okay, yeah, it's in there, and it's talking about the parallel circuit. And,
okay, yeah, I remember that. I just didn't know how to express it.
Okay.
Okay. All right. Thank you.
You're welcome. Okay. Anything else?
I'm gonna have to get with you on 22 as well, because I don't know. I just wasn't having a good start on that. So okay. Let me do this and we'll work on that later.
Yeah, I think we should have some free time tomorrow after Mr. Ty's lecture. Usually on Thursday, we have a lot more time to work on this.
All right. Thank you.
All right. You're welcome, Matt. Okay.
Bye-bye.
Take care. Bye-bye.
Okay. Good night.
Night.
Good night, sir.
All right.